Welcome to the AutoSys training video. By the end of this video, you will learn about virtual resources in AutoSys and how to control the job runs using these resources. To enhance the learning experience, we will use an example of a fictitious bank called the Hedmerl Bank and demonstrate how and when to use virtual resources to control the job executions in AutoSys. Before we go through the Hedmerl requirements and challenges they face, let's understand what a virtual resource is, how it functions, and the different types of resources available in AutoSys. AutoSys resources are abstract representations within the job used to manage and allocate resources required for various tasks and processes. Resources are classified as virtual as they serve as placeholders or symbolic representations within the scheduling environment and are directly not tied to any physical components. By strategically allocating resources, developers can regulate the execution of jobs by restricting the number of concurrent jobs running on a specific machine or globally across the entire AutoSys instance. Using resources, the developers can create dependencies enabling the job to run successfully. A job with resource dependencies can only be executed when the required resources are available. This granular control ensures that critical tasks are prioritized while preventing resource contention and maximizing the efficiency of job execution. There are three types of virtual resources in AutoSys: depletable, renewable, and threshold resources. A depletable resource is a consumed resource. When you submit a job with a depletable resource, the job uses the resource and removes the depletable resource permanently from the resource pool. You can only replenish the resources if you want more depletable resources. A renewable resource is a borrowed resource. The job borrows the resources to execute successfully. When AutoSys submits a job, the job removes the renewable resource from the resource pool temporarily and returns to the resource pool when the job completes execution. A threshold resource is a sizing resource. A job doesn't remove the resource from the resource pool while running. You can think of a threshold resource as a variable height doorway into the system. If the resource quantity is set to 2, AutoSys submits any number of jobs requiring 2 or fewer units of this resource. Any job, however, requiring 3 or more units is too high to pass through the door, therefore AutoSys doesn't submit them. AutoSys sizes the job against the current level of the threshold resource. You can create, update, and delete a resource using the relevant GIL subcommands in AutoSys. In this video, let's focus on using a depletable virtual resource in a fictitious scenario to understand how resource availability controls job execution. The Hedmerl Bank uses a third-party reporting solution to generate monthly financial reports. The IT department at Hedmerl Bank integrated the reporting tool into their banking system, enabling the automated generation of reports. The reporting tool provides an API that allows the bank to send requests to the tool to generate monthly financial reports, customer account statements, and profitability reports. However, the tool charges the bank based on the number of access requests made to their system through API for generating multiple reports. To manage the costs, the bank has opted to restrict the number of API requests by creating a batch process job for multiple report generation. If additional API access is required, the team can increase the resources on demand with an appropriate approval process. The workload automation developer decided to use the depletable virtual resource to control the execution of the batch processing job. The batch process job connects with the reporting tool if the resources are available and generates the relevant reports. Let's enter our training environment and test the functioning of the depletable resource. We will also assign the resource to the batch job and then run the job to verify that resource usage. For this demo, we assume that the environment settings for AutoSys are already in place. To create a resource using a GIL script, connect to the AutoSys server running on a Linux operating system and open the primary and secondary shell prompts. In the primary shell prompt, enter GIL and press enter. The GIL interface opens. Insert resource and define the resource attributes. Provide a unique name for the resource. Specify the resource type as depletable. Provide the target machine name. Ensure that the specified machine is defined within AutoSys and that the system agent is installed. If not, the job fails. Specify the resource amount as 5. Now type exit and press enter to create the resource. The GIL interactive mode ends and the resource object is created in the database after the GIL interpreter validates it. The resource object returns the exit code 0 if the resource creation is successful. Let's assign the resource to an existing job as a dependency. In the shell prompt, enter GIL and press enter. The GIL interface opens. Open the batch processing job using the update job subcommand. Assign the resource and specify the quantity as 5. This assignment ensures that the batch job starts only when 5 units are available. Now type exit and press enter to save the job. The job returns the exit code 0 indicating the successful batch processing job update. To monitor the job event logs, let's run the AutoSys log command with Option E in the secondary shell prompt. And manually start the batch job using the send event with appropriate options in the primary shell prompt. If the start conditions are met, the job starts. You may notice that the AutoSys log command utility displays the event log showing the current status of the batch processing job in the primary shell prompt. The event start job triggers the job start. The job verifies the availability of 5 units of virtual resources. If the 5 units are available, the resource dependency is successfully satisfied. Then the job uses the available 5 resources and goes into the running state. The job generates the necessary reports, completes with a success state, and returns an exit code 0. As the depletable resource is consumable once a job consumes the resource, the other jobs or the same job after execution awaiting the resource availability will go into the reswait state. The jobs start execution only when the depletable resources are replenished. The IT team decided to use the same reporting tool to generate credit card statements. The credit card statement batch job requires access to the report generation tool. Let's enter our training environment to run the batch job for credit card statement generation, to learn how to update the depletable resource object, and monitor job status changes before and after the availability of depletable resources. Run the AutoSys log command with Option E in the secondary shell prompt to monitor the event log of the batch processing job for credit card statement generation. In the primary shell prompt, manually start the batch processing job using the send event command. In the secondary shell prompt, you may notice that the job enters the reswait state as the resources are unavailable. The batch processing job for report generation consumed the resource units we initially added. In the primary shell prompt, type GIL to open the GIL interface. Update the resource using the update_resource subcommand. Specify the target machine. And increase the resource amount by 5 units. Type exit and press enter to save the resource object changes. The resource object returns the exit code 0 if the resource update is successful. Once the resource units are available in the secondary shell prompt, you may notice that the job in the reswait state changes to the running and then to the success state. In this video, we focused on the functioning of depletable resources. We will learn about renewable and threshold resources in the job load balancing videos. Thank you for watching the video on virtual resources.